Hey everyone, today we are going to start comparing rational numbers. Rational numbers mostly include fractions, and they also include both positives and negatives, so we're going to be doing all of these things. We are going to use different look-fors in order to compare these things, so I have them numbered to help you out. We're going to look at several different examples in those look-fors, so a couple different examples of each one. First, we're going to talk about negative land a little bit. In negative land, the more negative you are, so the more negative the number, the smaller the number. So as you go further to the left on the number line, the smaller that number actually is in relation to 0. So it's a little bit different than positive numbers. You have to almost think of them as the opposite. So we've got several different look-fors that we're going to use. Look-for number 1 is positive versus negative. Positive numbers are always greater than negatives. Right then. So when you are looking at comparing two numbers, if you notice that one is positive and one is negative, the positive is always bigger than the negative, no matter what the fractions are. So 7/8 is going to be greater than negative 2/3. 1 5/7 is going to be greater than negative 1/2. Because a positive is greater than a negative. Look for number 2 is where we compare to 1 or negative 1. So as I am looking at these fractions, one of them is greater than 1 and one of them is less than 1, or one of them is less than negative 1 or greater than negative 1. What I like to do on these ones, especially when there are negatives, is I like to draw a little number line that goes from 0 to negative 1. And then I want to ask myself, okay, where does negative 8/7 fall on this number line? Does it fall on the 0 side of a negative 1 or on the negative 2 side of negative 1? So negative 2 is over here, right? So negative 8/7 is bigger than 1. So it represents more than one whole. It's just a negative. So I'm going to put negative 8/7 on the left side of negative 1 because it is past negative 1. And then negative 4/5 is on the 0 side of negative 1. That means that negative 8/7 is actually less than negative 4/5. Because the further away from 0 I get towards the negatives, the smaller the number actually is. If I do the same thing for number 2, I'm going to go this way. So 0, 1, and then 2 here at the end. 10/3 is actually going to be bigger than 2. So 10/3 is going to be somewhere over here. And then 9/10 is less than 1. So I know that 10/3 is bigger than 9/10. That improper fraction is going to be bigger than a fraction that is proper. So this is look for number 1 and look for number 2. Look for number 1 is positive versus negative. Look for number 2, we're comparing to 1 or negative 1. And again, on that comparing to 1 or negative 1, a number line might be helpful, especially at first. Look for number 3 says mixed numbers that have different whole numbers or integers. So what I'm looking for in this one is I am comparing a negative 2 and a negative 3. Because those mixed numbers have different whole numbers, I can compare those whole numbers because the fractions don't really add anything extra to that. So in this case, negative 2 and 2/3 is going to be greater than negative 3 and 1/3 because negative 3 is further away from 0 into the negatives. In this one down here, I need to change this into a mixed number. So I'm going to say, okay, how many times does 3 go into 8? 3 goes into 8 2 times. And I've got a 2 left over. So this is actually negative 2 and 2/3. And I'm comparing it to negative 1 and 7/8. And now I can compare those whole numbers because they're different. And negative 2 2/3 is going to be less than negative 1 7/8 because negative 2 is further away from 0. Look for number 4, comparing to 1/2 or negative 1/2. Again, I'm going to draw a number line on this one. So I've got 0 and I've got 1, and then 1/2 is here in the middle. Now when I look at 2/7, half of 7 is 3.5. 2 is less than 3.5, so 2/7 is going to fall somewhere over here. It doesn't have to be perfectly accurate. I'm just saying that it falls somewhere on that side of 1/2. 7/9, half of 9 is 4.5. 7 is bigger than 4.5, so it's going to be somewhere over here. And I can clearly see that 2/7 is more to the left of my number line, so it is the smaller number. So 2/7 is less than 7/9. Now in negative land, here's my 0, here's my negative 1, here's my negative 1/2. Negative 5/12 is less than 1/2, but it's actually greater than negative 1/2. So negative 5/12 is going to be somewhere over here. Because remember that in negative land, it's the opposite. So if I am less than 1/2, I'm actually greater than negative 1/2, so I'm closer to 0. And then negative 8/15 is going to be on this side because 8 is more than half of 15, so it's going to be on the left side of negative 1/2, which actually makes it the smaller number. So the more negative I am, the smaller the number actually is. So negative 5/12 is greater than negative 8/15. Okay, so look for number 3, look for those different whole numbers. Look for number 4, we're comparing to 1/2 or negative 1/2. Look for number 5, I'm going to call this number 5, and then this one is going to be number 6. In look for number 5, we want to compare the same numerator. So sometimes getting the same denominator is not convenient. In these ones that I have here for examples, they're not too bad, but we're going to give you some more complicated examples that getting the same numerator is not as easy. So in this one, I'm going to multiply by 2, and I'm going to get 14/16, and then I've got 14/19. And the way I like to think about the same numerator is if I was sharing the top with however many people on the bottom. So I used gum. So if I have 14 pieces of gum, who would I rather share with? Would I rather share with 16 people or 19 people? And I would rather share with 16 people because I'm going to get a bigger piece of gum. If I'm going to get a bigger piece of gum, then that number is bigger. So 14/16 is greater than 14/19. Now, when we're looking at it in terms of negatives, so I'm going to multiply this by 3, and I'm going to multiply this by 2. So 6/45, and it's negative, and then negative 6/28. If I have 6 pieces of gum, I would rather share with 28 people because I'm going to get a bigger piece of gum. But in negative land, if I'm getting a bigger piece of gum, that number is actually smaller. So negative 6/45 is greater than negative 6/28. Because if I'm looking at the bigger number, in negative land, it's the opposite. In look for number 6, we're comparing the same denominator. So I'm going to make this a 12 and this a 12 as well. So here I'm making the denominators the same because we're going to compare the same denominators. So this is going to be negative 9/12 and then negative 10/12. Now, when you're comparing with the same denominator, if the number of pieces that you're breaking it into are the same, you can just compare the tops. Negative 9 is negative 9 is greater than negative 10 because when we're thinking in negative land, we have to think the opposite, right? So negative 9 is closer to 0. So negative 9 is actually greater than negative 10. If you look at it in terms of just positive 9 and positive 10, you have to flip it at the end. So 10 is greater than 9, which means that negative 10 is less than negative 9. On number 2, I'm going to go to 24. So I'm going to multiply by 2, and I'm going to multiply by 3. So 10/12 and sorry, not 12, 24, and 9 over 24. Now, when they're both positive, you can look at them as they actually are. So 10 is greater than 9, so 10 over 24 is greater than 9 over 24. The last one that we are going to look at is when the same whole number appears in our mixed number. So you can see here I've got -2 and -2. Here I've got -3 and -3. At this point, I can use any of the look-fors that I have available to me. And just pick one. So when the whole numbers are the same, I have to compare the fractions to see which one's bigger and which one's smaller. So this one, I can see that the 4s on the bottom are already the same. So I'm just going to use the comparison of the denominators. Well, 1 over 4 is less than 3 over 4. So -2 and 3/4 is the bigger number if it's positive, which means it's smaller when it's negative. So -2 and 1/4 is greater than -2 and 3/4. So here I used number 6, same denominators. In number 2, I'm comparing 7 over 8 to 2 over 3. And there's a couple different ways you can do it. You could get the same numerator, so I can do 14 over 16 and 14 over 21. Or I can do the same denominator, and I can get 21 over 24, and I can get 16 over 24. Either way, you are going to get the same answer out of your comparison. These are the two most convenient comparisons, the same numerator or the same denominator, because both of these numbers are bigger than 1/2. Neither one of them is bigger than 1, so that doesn't work. They're both negative, so positive versus negative doesn't work. So this is going to be the most convenient of the two options. 7 over 8 is bigger than 2 over 3, but we have to go back to remember that they're negative. So in negative land, the bigger number is actually smaller. So -3 and 7/8 is smaller than -3 and 2/3. Now I've got some practice here on the notes for you guys to try with each of the look-fors. So there's 6 questions, there's 6 look-fors, so you can use each one of them once. And then the homework is designed the same way. In each row, there are 6 questions, and there are 1 of each of the look-fors on that page as well.